Wabarakatuh. My name is Muhammad Ilman Mugni. In this occasion, my group decided to choose problem 5 between these three problems provided, and I want to show you all our work, my group discussion about how to accomplish this problem, specifically how to determine deflection and reaction forces of the truss member shown in this figure, using finite element analysis with the utilization of OpenModelica software. Okay, I will just straightforward to the explanation. So, as we can see at this case, having 4 elements, each of them consists of 2 nodes. In element 1 consists of node 1 and node 2. Element 2 consists of node 2 and node 3. And this is the theta. Theta is the represented the angle of each beam. In element 1, the angle is 0 degree, and for the element 2, in this beam, it has the angle of this 146 degree, and so on. And this is the value of K. Probably all of us will be more familiar with the constant of stiffness, denoted with K. We can see here the value of K is different for each element. For example, is the element 1 and 3 is this much, and so on. And then we must develop the K value with these cosine equations. And if we want to consider the stiffness constant of element 1, we're supposed to input the angle value in element 1, which is 0 degree, like this. And then likewise with other elements. And after that, we have to develop it again into global system with a larger scale of 8 times 8 matrix, like this. So the total global system of K value is given like this, as shown. And then we apply the boundary conditions, if there is any. From the figure, we know that in node 1 and node 3 are connected with fixed joint, which implies the deflection at the nodes are 0. So here are the results. For the reaction forces is this number, and for the deflection is this matrix. And then now I want to explain the analysis with numerical method using OpenModelica software. Okay, firstly we have to make a new file of model specialization. Model generally can contain variables and equations, like this, as shown in the slide. Okay, so the first is we shall define all the parameters that is provided by the problem, such as sum of nodes and area, modulus elasticity, and so on. Then we have to input them value in SI units, and then we input the external forces in this that subjected to the member. As we can see at the previous slide, the external forces acted just on the for not 4, and the external forces is in the negative y direction. So I write it on the on the worksheet is like this. Minus 10,000 Newton. And after that, we make the boundary conditions at the nodes 1 and 3, as I mentioned before, and defining the equation in each element or in each truss like this. Since we have the total of truss is 4, we just make the equation of that 4 element. And then we create the global matrix of stiffness constant algorithm like this. Then we made stiffness matrix equation algorithm, the global system of stiffness algorithm, then the reaction forces algorithm, the Gauss-Jordan algorithm for the finishing method. Those algorithm is written in function specialization because those will be called at those function will be called at model specialization at the because this function will be called in this model as the finishing. And then we have to as the last steps, we have to execute the algorithm or the syntax. So here are the results. It is the graph of reaction forces described with red line, and the graph of displacement described by the blue line. And here are the exact and here are the results of the reaction forces and the displacement. And this is the local displacement in terms of the global displacement. And then here are the exact calculation of internal forces and normal stress of the members using formula referred to related reference. Okay, maybe that's all from me. I'm sorry if there was a mistake. Assalamualaikum warahmatullahi wabarakatuh.